So basically this Wien's distribution law actually failed. Okay, failed to describe the intensity distribution of the black body radiation. So now now these two scientists called as Rayleigh and Jeans, okay, Rayleigh and Jeans, they actually tried to explain this. Okay, now how did they explain? Rayleigh and Jeans in the year 1900 tried to explain the black body radiation. Okay, so how did they explain? So they considered the black body radiation. It is actually taking place in a cavity. Okay, it is taking place in a cavity, just like how I had drawn that. It is taking place in a cavity like this. This is a black body. Okay, now here this black body consists of what? Atoms. Here there are atoms in the on the surface of the black body. There are atoms. Okay, on the surface of the body there are atoms like this. Now what will happen when the black body is heated? What will happen? These atoms will also be heated, and when they are heated they will what the atoms will vibrate. The atoms will vibrate on heating, and when they are vibrating means what? They are oscillating. Now they are oscillating means what? They means they will they are accelerating. Oscillation means they will have an acceleration. In simple harmonic motion will have an acceleration. Okay, now when an accelerating particle, you know that an accelerating particle, charged particle, accelerating uh, charged particle, charged particle emits electromagnetic radiation. Emits electromagnetic radiation. Accelerating charged particle emits electromagnetic radiation. Okay, so what will happen when they will emit electromagnetic radiation like this? Okay, like this, they will emit electromagnetic radiation. This atom will also emit electromagnetic radiation. This atom will also emit electromagnetic radiation. Okay, now all throughout this cavity there will be electromagnetic radiations like this. There will be electromagnetic radiations like this, and they will what they will do, they will collide with the walls. Okay, this and get reflected back. This electromagnetic wave will flow in this direction, they will collide with this wall and then get reflected back. This also will get reflected back. Okay, and as a result of which, what they will do, they will produce stationary waves. Okay, stationary waves will be produced. As a result of this, stationary waves will be produced. Okay, stationary waves will be produced. Now now what will happen? The the atoms are oscillators. Okay, so energy is exchanged between the atoms and the walls. So the energy within the cavity will finally reach an equilibrium condition at a certain constant temperature. Okay, now what will happen? This because of this stationary waves will be produced. Stationary waves is also produced in the chapter which I had earlier taught you, that is laser. Okay, so what will happen? Stationary waves will have various modes. you have studied this already in class 11. They will have various modes. This is the fundamental. Okay, then they will have this one. Okay, okay, like this. This kind of many modes will be produced like this. Okay, now all the stationary waves will, there will be many stationary waves produced. Okay, but all the stationary waves will not be not satisfy the condition. Okay, what will satisfy the condition? Suppose this is the length of the cavity. Okay, now if this L will be equal to say n into lambda by 2, only then only the stationary waves will be generated. Otherwise the others will not be generated. Okay, they will not produce a wave. Only the waves which will, only the waves of wavelength lambda which will satisfy this condition, that L is equal to n lambda by 2, only those waves will produce these stationary waves. Other waves will not be produced. Okay, so this will be n into lambda by 2. So now this thing is very interesting. Now see here again, this is what this is called as the node. Okay, the nodes will always be produced at the ends of the tube. For the fundamental, the nodes will always be produced at the ends of the tube. Okay, because this is an electromagnetic radiation, electric field. Now electric field, nodes cannot be produced here. Okay, because electric field at the end, when this is a metallic conductor. Okay, so for a conductor, what happens? The electric field is from the surface, it acts perpendicularly like this. Okay, so this has to be produced at the antenna has to be produced at the two ends. Otherwise it will not be produced in between here for the fundamental. Okay, so now if now T is increased, if the temperature is increased, then then new modes of standing wave, if temperature T is increased, new modes of standing wave are will be generated, will be new modes of standing waves will be generated. Okay, and also amplitudes of existing mode, amplitude of existing mode will increase. Okay, this is the amplitude of this mode. Okay, so this amplitude also, like it can increase like this much also. Okay, Achha, now so all throughout this black body, this kind of standing waves will be generated. All throughout this black body, this standing wave will be generated, and this will produce basically the energy of the black body radiation. Okay, this will produce the energy of the black body radiation. Now the energy, there will be an energy density of radiation. Okay, so the energy density energy density of radiation or energy density of radiation, that is the amount of energy, the energy density, the amount of energy per unit volume corresponding energy density of radiation, it is denoted as U nu. Okay, amount of energy per unit volume corresponding to the radiation with frequencies lying between nu and nu minus d nu. Okay, that will be what? That will be actually the energy density of radiation U nu per unit corresponding to radiation with frequencies lying between nu and nu minus d nu. That will be what? The energy density of radiation U nu within the frequency range nu and nu minus d nu. That will be U nu into d nu. Okay, that will be U nu into d nu. Now U nu into d nu will be what? U nu into d nu will be, if say epsilon A is equal to average energy of a standing wave. Epsilon is the average energy of a standing wave at absolute temperature T. Okay, and N nu d nu, this d I am cutting, N nu d nu will be what? N nu d nu will be the number of standing waves per unit volume or density of electromagnetic standing waves. Okay, this is also told as the number of oscillators. This is also called as the number of oscillators because these oscillators are only producing the standing waves. Okay, so N nu d nu is equal to number of standing waves volume. so if you multiply the number of standing waves with the average energy, you will get the total energy density. So that will be N nu d nu into epsilon A. Okay, that will be N nu d nu into epsilon A will be the total energy density of radiation in the frequency range nu and nu minus d nu. That will be the average energy of the standing wave multiplied by the number of standing waves per unit volume. Okay, that is the number of oscillators. Okay, so number of standing waves, you can also denote this as the number of modes. Okay, you can also denote it as the N nu d nu this is also called as the number of modes of vibration. Okay, number of modes of vibration. So number of modes means here this one is n is equal to 1. Okay, then this one is n is equal to 2, this one is n is equal to 3, this is third mode, like this. Okay, the number of modes. Now Acha, this n new d new, we have to calculate this n new d new. Okay, so how will we calculate this? Okay, so you know that here standing waves are produced. So what is the equation of standing wave? Equation of standing wave, y is equal to a sine k vector dot r vector into cos of omega t. This is the equation of standing wave. Okay, so here k vector dot r vector is kxx plus kyy plus kzz. Okay, where k square is equal to kx square plus ky square plus kz square. Okay, now kx is equal to nx pi by a, ky is ny pi by a, kz is nz pi by a. Okay, where k is called as the wave vector, which is 2 pi by lambda, wave vector or propagation constant, or wave vector, propagation constant or wave vector, which is equal to 2 pi by lambda. Okay, so from here what will you get? You will get pi square by a square into nx square plus ny square plus nz square. Okay, so from here what will you get? So this is actually pi square a square into n square. Okay, where n square will be what here? Here n square will be very nice. This same thing here. This formula. This L is equal to n lambda by 2. Okay, L is equal to n lambda by 2. Achha, what is A here? A is the actually size of the, suppose instead of L, say this is A. So this will be A. A is equal to n lambda by 2. Okay, this is n lambda by 2. So from here what will you get here? So this is equal to pi square by a square. Here a is equal to n lambda by 2. Okay, so from here what will you get here? N square will be 4a square by lambda square. So this cancels, so this will be 4, oh sorry, n is pi square by a square, and n is what here? N is 2a by lambda. N is 2a by lambda. Okay, so cut this here. So from here what do you get? From here n square is equal to a square by pi square into k square. Okay, so if you put here a square by pi square into k's value, if you put, k will be what? 4 pi square by lambda square. So this will be 4 pi square cancels, 4a square by lambda square. N square will be 4a square by lambda square. So if you convert this to nu, what will you get? Lambda is equal to c by nu. Okay, so this will be 4a square nu square by c square. Okay, 4a square nu square by c square. Acha. Now what do you have to do now here? You have to calculate n nu d nu. you have to calculate here n nu d nu. So how will you calculate n nu d nu? So for that, all possible standing wave can be represented as a lattice point in the all possible standing wave can be represented as a lattice point in the positive octant of the space whose axes are nx, ny, nz. Okay, so how will you represent that? You will draw this axis. Okay, like this. This is nx, this is ny, this is nz. Okay, and so these will be the, you have to take only the positive values of nx and ny. So how will you write it? It will be only in this octant, and you will draw a sphere. You will draw a sphere like this. Okay, you will draw a sphere having radius n. Okay, you will draw another sphere here having thickness dn. So since n is positive value, you have to calculate only in this octant. Okay, so so now this n nu d nu. Okay, this n nu d nu will be what here? N nu d nu. How will n nu d nu? How will you get this? N nu d nu will be the the volume of this sphere. What is the volume? Volume is 4 pi n square into dn. This is the volume. Okay, and since you are taking only 1/8 part, if you take this octant only, it will be 1/8 of this. Okay, 4 pi n square dn. So this will be pi by 2 into n square dn. Okay, pi by 2 into n square dn. Now what you have to do here is that, since you are taking electromagnetic waves have got two polarizations. I had done in your polarization class also, that is, it has got two polarization. One is one is vertical and another one is horizontal. Means how do you represent a polarized wave? You represent it like this. Rather, unpolarized wave you denote is like this. One is this along this direction, another one is along this direction. Okay, so two components. So you have to, for that you have to multiply this by 2. So it will be pi n square dn. Okay, so this will be, what will you get here? Pi into n square. What will you write in the value of n? You have to write now. What will be the value of n? N here is 2a by n is here. If you want to write it in terms of nu, what will be? This is a is equal to n lambda. lambda is equal to c by nu, so nc by 2 nu. Okay, so so here n will be here, n square, n will be here, this is n 2 nu a by c, so 4 nu square a square by c. Okay, and dn, what will be dn? So here if you write n here, n is what? N from here, if you write n is this one, n is 2 nu a by c, 2 nu a by c. So what will you write? dn, dn will be 2a by c into d nu. Okay, so dn will be 2a by c into d nu. So this will be 8 pi a cube into nu square d nu by c cube. Okay, 8 pi a cube. So this will be thing. Acha, now a cube is what? A cube is the volume of the cavity. Okay, a cube is the volume of the cavity. So if you do what is n nu d nu? N nu d nu is equal to the 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 number of modes per unit volume. Okay, see here the n nu d nu, number of standing waves or number of modes of vibration per unit volume, per unit volume. Okay, per unit volume. So so n nu d nu will be what? N nu d nu will be 8 pi nu square d nu by c cube. This will be n nu d nu. Okay, so now here what did you get here? U nu d nu is equal to this one. U nu d nu is equal to n nu d nu into epsilon a. Okay, so n nu d nu into epsilon. So n nu d nu you have got, so 8 pi nu square d nu by c cube into epsilon a. Okay, now what is this epsilon a? Average energy of the oscillator. Okay, average energy of the oscillator. Now from the equipartition theorem, epsilon a is equal to what? Epsilon a is equal to kt, where kbt, where kb is the Boltzmann constant. Everybody knows where kb is the Boltzmann constant. Kb is the Boltzmann constant. Okay, kb is the Boltzmann constant. Acha, this u nu d, that's n nu d nu. Okay, n nu d nu is equal to this. I have again drawn all these things, and here you no need to do that. That is not there so much in the syllabus. If you directly write n nu d nu is equal to 8 pi nu square d nu by c cube, that is okay, no problem. You just put n nu d nu formula in n nu d nu formula in this space, so you will get the answer. Okay, acha, so epsilon a is equal to kbt. Okay, so from here you can write that u nu d nu will be equal to 8 pi kt by c cube into nu square d nu. Okay, acha, now what is the why are you doing this? You are doing this to find out the intensity distribution, that is E lambda versus lambda. Okay, E lambda versus lambda you have to find out. So that means you have to find out this in terms of lambda. So how will you do this? So just simply from this formula you have to do nu is equal to c by lambda. Okay, so d nu will be minus c by lambda square d lambda. Okay, d nu is equal to minus c by lambda square into d lambda. Okay, and here you see here that d nu means, just if you consider d nu will be what, equal to minus d lambda. Okay, means increase in the frequency will be equal to decrease in the lambda. So from here what can you write? U lambda, this just you are writing this thing. Okay, u lambda d nu you are writing as d lambda. Okay, so for that d nu you are writing as d lambda, there will be one minus, so minus 8 pi kt by c cube into nu square, you write nu square as c square by lambda square, and d nu again you write d nu you write here as minus c by lambda square into d lambda. So what do you get? This minus minus cancel, so this is c, this is c cube, this is c cube, so c cube q cube cancels, so 8 pi kt by lambda to the power 4 into d lambda. Okay, so this is called as the acha, that is u lambda. Okay, so what do you get here? U lambda is equal to 8 pi kt by c to the power 4 8 pi kt by, sorry, not c to the power 4, lambda to the power 4, 8 pi kt by lambda to the power 4 into d lambda. Okay, no need to write here. You see here, this is u lambda d lambda, so u lambda will be what? Here is also d lambda, here is also d, so u lambda will be what? 8 pi kt by lambda to the power 4. So from here what you can write? So u lambda is equal to 8 pi kt by lambda to the power 4. Okay, now what is the relation between this is energy density of radiation and this is the emissive power. Emissive power is equal to c by 4 into u lambda. Okay, so from here what you know, E lambda will be equal to c by 4 into 8 pi kt by lambda to the power 4. So this will be what? 2 pi c kt by lambda to the power 4. Okay, this is a very important derivation called as the Rayleigh Jeans law. This is called as the Rayleigh Jeans formula or law of radiation. Rayleigh Jeans formula, law of radiation. Okay, now comes your this thing. So from here, now if you come to so they have done this. Okay, so what did Wien found out? Wien had found out this thing. Wien had found out Wien's distribution laws. What Wien's distribution laws? E lambda d lambda is a by lambda to the 5, f lambda d lambda. So this failed. Okay, then Rayleigh Jeans tried to modify it. So what came now? It came E lambda is equal to 2 pi c kt by lambda to the power 4. Okay, now you see a very interesting thing, that if you plot again E lambda versus lambda, what do you get? You get this thing. Okay, so this is lambda m. This is the experimental value. Now say if you plot this thing, you see, you take the lower values of lambda and higher values of lambda. Okay, so if you take the higher values of lambda, say lambda tends to infinity. So from here, if lambda tends to infinity, then E lambda tends to 0. So okay, E lambda tends to 0 only here for lambda tends to higher lambda. Now if lambda tends to 0, here if lambda tends to 0, then what happens? E lambda tends to infinity. E lambda will tends to infinity, but see here, is it turning to infinity? No, it is not turning to infinity. So what will be the I mean, how will the here look like? It will look like this. The experimental curve will look like this. It will shoot up like this. It will shoot up like this. Okay, not so much also. It will do like this, like this. Okay, so there is a discrepancy. There is a discrepancy between the experimental graph and the Rayleigh Jeans graph. Okay, between experiment and theory. This is called as the Jeans paradox. This is called as the Jeans paradox or the ultraviolet catastrophe. Ultraviolet catastrophe. Why it is called ultraviolet catastrophe? Because actually this region is the UV region. Okay, this region is the in the UV region. The experiment and the theoretical value doesn't match. Okay, they are completely mismatched. So this is called as ultraviolet catastrophe. Okay, this is called as ultraviolet catastrophe. The between the experiment and the theory, there is a huge discrepancy. This is called as the Jeans paradox or ultraviolet paradox. So if in exam it comes for 2 or 3 marks, you have to write this formula that according to Rayleigh Jeans formula, E lambda is 2 pi c kt by lambda to the power 4. So if you put lambda tends to infinity, E lambda will tend to 0. So according to the experimental graph, E lambda tends to 0, no problem. But if lambda tends to 0, then E lambda tends to infinity. But for experiment, E lambda tends to 0. So I mean there is a huge discrepancy there. This is called as the Jeans paradox or ultraviolet catastrophe. Okay.